welcome to Leetcode YouTube channel. If you are new to this channel, I'll highly recommend you to subscribe to my channel as I make content related to software engineering, system design, and data structures and algorithms. Today we are going to solve this Leetcode problem number 353. The name of the problem is Design Snake Game. So let's check out the problem statement quickly. So this problem states design a snake game that is played on a device with screen size, width into height. Play the game online if you are not familiar with the game. Okay, so the snake is initially positioned at top left corner 0 0. Okay, and the length of the snake is 1 unit, and we are given a list of foods position, okay, in row column order, basically coordinates. So when a snake eats the food, its length and the game's score both increases by 1. Each food appears one by one on the screen. Okay. For example, the second food will not appear until the first food was eaten by the snake. So the next part is like when a food does appear on the screen, it is guaranteed that it will not appear on a block occupied by the snake. Okay, basically the food won't appear at the coordinate where the body of the snake is already present. So this problem I think will become more clear when we'll go through this example. So let's come to this example. So what it tells is that we have a board or screen with width 3 and height 2, and food is located at 1 2 and 0 1 coordinates. Okay, so initially only 1 2 food would be available, and once this is eaten out, then 0 1 food will become available. Okay, so new snake, this kind of constructor would be provided to us, and initially the snake appears at position 0 0 and food is at 1 2 as depicted by this matrix. Okay, so the first command he gives is he calls the move function with r as the argument. So this should return 0. Okay, because the food is not present on the right side and size of the snake is same, or like score is not increasing. So here initially we can assume the size of the snake as 1 and score is 0. So there is a relation between size and score, like score is always equals to size minus 1. Okay, so in this example he has talked about the score, but you can also solve this problem for the length of the snake. Okay, so now he gives R command and our snake moves towards right side. Now snake is present here. Okay, now he gives down command and our snake points here. Okay, still there is no food, so length is same and score is same. Now he gives R command. Okay, so food is present on 1 comma 2, this one. Okay, so this food he eats and his length increases by 1. Okay, so this is the snake now, and our length is 2 and score is 1. Okay, now what happens at this moment is the next food starts appearing. Okay, so the coordinate of next food was 0 1. So 0 1, here the food starts appearing. Okay, so food appears here. Okay, now he gives the command as up. Okay, so our snake will become like this. Okay, so length is still same or score is still same, it will return length minus 1 or score, which is 1. Now he gives left command. Okay, now the food is present here and he gives left command, so size is bound to increase by 1. So the size would now become as previous plus 1. Okay, size would become as 3. This is my snake. Okay, now he gives the command as up. Okay, so what will happen when he'll give this up command? So on giving this up command, the snake will hit the boundary of this matrix, right? So in that case, what we are supposed to do is we are supposed to return -1 or like finish the game, because like snake collides with the border, and in the classic snake game, this ends the game. Okay. So there is one more thing where you need to be careful, which is snake should not bite itself. Let's say our snake is like this, and if we take a move like this, right? So game should also become over when snake bites itself. Okay. So these two things you need to be careful while solving this problem. So I hope like the problem statement is a bit clear now. So like this is the uh, kind of class we want to make, and like these kind of constructor we want, and this this food would be provided. Okay, so you can assume like the output of these to be like this as given in the example. Okay, 0 0 1 1 2 -1. So the snake initially starts from here, right? And food is here. Okay, so he like the user gives a write command. Okay, so what will happen? Snake will move to next block. So snake will move here. Okay, so now let's move to the next command. Okay, so the user gives down command. Okay, so what will happen now is the score or the size of the snake is going to remain same, and the snake is going to come down by one step. Okay, snake is here now. Now again the user gives write command. Correct. Now what will happen? So at this point, this food will be eaten by the snake. Okay, so size of the snake is going to become the previous plus 1. Okay, the snake size is 2 now. Now at this moment, the second food item will appear, which is this. Okay, and this food is eaten. Okay, so now this is the state after third call. Now what he do is like he gives fourth command or up command. Okay, so what will happen is now snake will move like this. Okay, so it will move like this. So size is still same, and we are returning 1 or size -1. Okay, now fifth command he gives, which is L. Okay, so with L what will happen is he'll eat this food. Okay, so this food is going to get vanished, and size of snake is going to increase by 1. So this is the state of the snake now, and now he presses the up command. So when he presses the up command, like this is my snake, and it will hit this wall. Okay, so it will hit this wall, so game will become over, and we are supposed to return -1 in that case. Okay, so this is the problem statement briefly, and how we want to implement it is on our own. Like we can use any implementation we find comfortable, or like more easier to visualize. So next I'll show you how I solved this problem. Let's have a code walkthrough. Okay, so this is the main class, and we have a snake game class. Okay, so in order to visualize any point in space, I have made a pair inner class. This has two variables or instance variables, x and y. It has a constructor, and I have overridden equals and hash code method because I want to use it for hashing. Like this will be used in a hash set, so I need to provide my own implementation of equals and hash code. So that I have provided. Next, let's try to trace the flow from the main method. So the snake game is a constructor. Let's go and check out that. So will be supplied width, will be supplied height, and we'll have a 2D array of foods. So what I'm doing here is I'm assigning these parameters to instance variable, and I have taken snake and foods as a linked hash set. Why linked hash set? Because first of all, linked hash set uh, retains order, like it stores elements. First of all, the elements are unique and then they are stored in the order of their insertion. So this is the main advantage of linked hash set. So why we want elements to be stored in order of insertion? Just because it would be easy to move the snake forward. Like when you want to move the snake in any direction, let's say this is my grid, right? Okay, so let's say here the snake is present and I gave the up command. So you want to move the snake from this direction to this direction. So what you want to do actually is you want to erase it from here and you want to put it here, right? So in linked hash set, what you are doing is you are removing the oldest element of the linked hash set and adding the new element. Okay, this will just move the snake forward. And the best part with linked hash set is that it provides us contains method, and using contains you can easily find whether you have landed over any food or whether you have like bitten yourself. So these type of checks you can like very easily put with this linked hash set. So that's about it. Let's move forward now. Okay, so this is a basic for loop I have used to put the foods in the linked hash set. Okay, nothing fancy here. Then I am adding the snake to this linked hash set snake. I'm assuming that a snake of size 1 is present at coordinates 0 0, and I am marking my instance variable x and y as 0, which is the current location of the snake. Okay, so now let's try to check the move method. Okay, so how is move method written? Let's check that out. Okay, so user can only give 4 commands, right? Up, down, left, or right. Correct. So if he gives any other command, then it's an invalid input, and I am directly returning -1 in that case. Okay, so that is it. And like the 4 command, let's say user gives up. So what I am doing is I am like on up I am reducing the value of x, on down I am increasing the value of x, on left I am decreasing the value of y, and on r I am increasing the value of y. First of all, this thing, and then what is happening in validate, let's check. So in validate, what I am doing is I am just checking that whether on that point snake already exists. uh, it is a case like snake has not bitten itself, something like this has not happened. And second thing which I am checking is the bounds. Okay, the bounds are correct, so everything is in the grid. So likewise, if the snake is bitten by itself, then I'm returning true, and if the bounds are crossed, then in that case I'm returning true. So validator is returning true on the like problematic cases. This thing you just need to take care. Okay, so what will happen now is I pressed up and it will validate everything is fine and snake has not bitten itself, and then it will reduce that instance variable value x minus minus, and then I'm going to actually change the snake size depending upon whether food has been eaten or not. Okay, so let's say let's check this change snake size method. Okay, so what is this doing? So this is nothing but this is getting foods as a stream and finding the first food. Remember that food appears one by one and we should eat the food which is present at the first position initially only, like rest of the foods are not visible. So what I am doing is in this if I am checking whether there is a food present at this place. So if food is present at this place, I am adding that to the size of the snake and I am removing the food from that linked hash set. Okay, so this will increase the size of the snake by 1 and this will remove the food from the foods hash set. So in the else part, what happens is food is not present at that place. So what happens is I need to do something like this. Okay, so let's say snake was like this. Okay, and I pressed an up. So what will happen is I want to remove this and I want to place this, right? So this is what I'm doing. So snake.addxy is doing this and this part is removing the last field. So basically size of the snake is going to remain same. Size of snake going to remain same. Okay, I think this change snake size method is also clear to us. So let's now scroll down a bit. So all the logic of up, down, left, right is similar and like the respective parameters are getting changed in terms of their coordinates. So let me bring you to this part. So this is just a kind of debugger statement. So if you want to check where the snakes are lying, you can mark this as true and on the console the position of snake would get printed, but in the actual problem while submitting you can mark this to false. And in the end what I am returning is the size of the snake -1, which is the score asked for the problem statement. Okay, so let me run this and I think you should be able to see the output over the console. Zero, zero, 1, 1, 2 and negative. Yeah, the output seems to be correct. So that's it guys. I hope you liked my tutorial. Please give it a thumbs up if this added any value to you, and once again thanks for watching this video. Hey guys, do check out this Instagram channel, Leetcode Community, for all the jokes and memes related to software engineering. Thanks a lot.